Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hot aqueous KMNO4 oxidize alkyl side chains on a benzene ring to carboxylic acids -CoO, provided there is at least one benzylic hydrogen. A tert-butyl group, no benzylic H, is resistant to oxidation. The product orthobenzenedicarboxylic acid, phthalic acid, requires two carboxylic acid groups at the 1,2 ortho positions of the benzene ring. Step 1. Identify what structure gives orthodicarboxylic acid. We need a compound that, after oxidation of its side chains or aliphatic portion, yields a benzene ring bearing CoO groups at the 1 and 2 positions. Step 2. Analyze option B. Option B is 1,2-dihydronaphthalene, more precisely tetryline or a partially saturated naphthalene analog. The structure shows a benzene ring fused to a 6-membered ring that contains a double bond and CH2 groups. When treated with hot aqueous KMNO4, the non-aromatic ring is cleaved oxidized. The two benzylic carbons, C1 and C2 of the saturated ring, which are attached to the aromatic ring, get oxidized to CoO groups. Because these two carbons are at the 1, 2 positions relative to each other on the benzene ring, the product is orthobenzenedicarboxylic acid, phthalic acid. This is the correct answer. Step 3. Why other options fail? A. Orthotert-butyl toluene. The tert-butyl group has no benzylic hydrogen and cannot be oxidized by KMNO4 to CoO. Only the methyl group would be oxidized to give a monoacid, orthotoluic acid derivative with 1 CoO, not a dicarboxylic acid. C. 1,4-diethylbenzene. Both ethyl groups are at para positions 1, 4. Oxidation would give 1,4-benzenedicarboxylic acid, terephthalic acid, which is the para isomer, not the ortho isomer. D. 1-methyl-3-propylbenzene. The substituents are at meta positions 1, 3. Oxidation would give 1,3-benzenedicarboxylic acid, isophthalic acid, the meta isomer, not the ortho isomer. Therefore, the correct answer is B. Therefore, the correct answer is option B.